Hello, hello, on bionichaos.com as per usual. Wanna see what can we change or fix, and also cover some other random stuff as per normal. Let me just post. Keeps asking me, LinkedIn asking me if I wanna post into these groups, but some of them are super weird. Well, content-wise, but also they review your post for like 14 days or something. But timing is crucial. So we haven't covered, we have some new tools that we haven't done proper explanation videos on. Because the video is actually easier to do than these descriptions. And then I can use the transcribed audio text on the website. Yes, say this one. Ooh, didn't work, did it? What's the link for this thing? Just going to a regular. Yeah, that's not good. I haven't tested this for a while. I have to change those bit. This link. There's no dedicated a video for that. There's a. This one's just opening way too large. This is probably my favorite. Yeah, and it has this. What's called YouTube Short. Yeah, there's something wrong with that video in terms of rendering. Sometimes it's, I think it's called screen tearing. Yeah, just moving my mouse too much. So shorts are kind of funny. They have to be this vertical screen, which, yeah, once the app is optimized for a mobile phone, then it will look okay on a vertical screen. But to begin with, I designed it all in a horizontal view. This one just comes up way too large. So this is 100%. I mean, it just fits the screen, so it's probably okay. Yeah, so I need the videos to put them on the site as a description. So some older ones would have had it. Yeah, like this one. Yeah, this has a proper video. It's also under a minute, but it's a horizontal view. It's not stuff. There is some. Yeah, sometimes they sound as funny volume wise. Sorry for that. I have to record those again, and sometimes, and also the transcription sometimes has a lot of mistakes. I have to manually go over it and correct stuff. Yes, there's a lot of things to fix. Like logistics wise. Logistic, plural. I don't know. This one should have a video to it as well. Yeah, it's a 2 minute, a bit longer. Must have been older. Yeah, you can hear the sound difference because I had an older microphone. It's actually not too bad most of the time. Yeah, then you have all these videos in here as well, but I have to get rid of it. I might actually put, yeah, well, first it's heavy loading, it takes forever to load. It's a YouTube embedded window. And second, I will just probably have the window in here instead of this text. Not sure what's the best place to put it, like at the bottom or the top, probably the bottom. And the text from the video transcribed in text here. Yeah. Still better than writing stuff. For me, takes forever. Was trying to make the videos shorter, but this is the YouTube built-in. What's that window? So say, yeah, this empty screen. If you wanted to remove something like that, you can. It's hard to find. It's just 1 second there. But yeah, this editor is kind of hopeless. It's a bit too simplistic. So currently I'm going over this, was it 2.5 hour stream, trying to shorten it, but it takes so long. I don't know, is there automated something that can remove silent bits, or yeah, you would like to detect silent bits like this, and also bits where there's nothing happening on the screen, so the screen is just stable. It should be pretty straightforward. Probably do it myself, but then I'm using a more advanced editor. Problem is that some of the live streams I didn't record on my own machine. So this one was downloaded off YouTube, but then it's much lower quality than originally recorded in, which is a bit frustrating. So now when exporting it, like not export, I can only do 1080p. The original it had this really weird resolution, which is a bit odd. Yeah, it has this 1280 on 720. So I can't even do 1080p, it's essentially 720. It's a bit frustrating that YouTube doesn't let me download my own video in the original resolution. because on YouTube you can select higher resolution, and it seemed to do something. Maybe it's fake. I wouldn't be surprised actually. Let's check the audio in another device. Right. It's there. I don't know what's the quality of it's like. The voice is crackling at best. Very crackly at the best of times. Anyway, in here, so this one you can do, with this editor you can do much more. For example, say this bit here, you can turn it into a much faster. So essentially 20 times the speed. It's just because there's nothing happening there. Probably have to put a label that it's 20 times speed, just so when you use the website, don't expect it to go this fast. It's actually, I actually can't do it that fast. On the other hand, it's probably obvious that that's being sped up. Ba, 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 ba. I keep forgetting that my OBS, the desktop audio is not going through into the stream, which is okay, but just have to remember that that's a default option. We're doing that as well. Do that offline. This one offline. We'll add the videos in here. Probably the actual YouTube insert window. This one doesn't have one. Have to go over all of them and see if we have a good quality video. Sometimes the quality of the actual screen here is not great, even though. So I don't know how does it look in the stream. Is it just where the bottleneck is? Right, because we also some of them is yeah, this function that allows you to zoom in. If this one is selected, you can use the mouse to zoom in and out. You can't scroll with the, so that could be great if you could scroll with the mouse as well. You need to use this scroll because it's loading, like in a matrix. Whatever you look at, that's the what's it's loading into your brain. Oops, that was not selected. Oh, it's a bit hard to navigate, but it's doable. And yes, ideally when you do this, it should load more stuff on the screen, but then whoop, just Gonski. Yeah. The other option would be having a transparent display like this, sitting behind the screen, so you could just do, so you can have both options. It would be nice. Yeah, screen size matters. a lot. I have this weird screen, that's why it's got, so actually all the stuff, the modem, like my um, webcam and the logo here. Oh, that's the end of is the logo is not. Oops. Is it, no, it doesn't end there. It's okay. So this logo, and I can't reach with my mouse because that's the end of my screen. That's the resolution of my screen. So it's probably not ideal for testing because most people would not have a screen like this. It's super wide and narrow, just can be somewhat annoying. Also planning like a video here. So this video that I'm recording now, eventually like an edited version of it could be placed on the site explaining what is it all about. But maybe we'll do like a dedicated recording just for that. We said we not, I thought I will not do development today, even though it's super tempting. Um, on the other hand, there's a lot of other things that I would like to touch on. I wanted to mention the MNE. It's this MEG plus EEG analysis and visualization with a Z, so all American. NIH funded. The reason I was looking at it is they have a Python module. I think they have a MATLAB module as well, which will be more convenient for me, but might be. I was looking to migrate into open source as well, so MATLAB or potentially R. So let me know which one is better, or if you have any suggestions. So far, I was having quite a lot of trouble with Python. Just getting things running was a bit of a struggle. There's all this essentially version control issues where there will be non-compatible things going on. Do I have any Python? So I don't have any Python on the site yet. I don't know how easy or difficult it would be to just post like a basic tool. Could try it out probably next week. So say if I wanted to have a basic example of this but written in Python, like how difficult would it be to just get it running as a web application? We also added, so in the overview here, we added a bunch of things. It's pretty much based on this PyEG paper from 2010, 2011. Yeah, the paper is pretty basic. There's some math in it, which I'm always struggling to go over. Show it to you and then close. That's what the paper is called. open source Python module for EEG feature extraction. Framework. So you input EEG. There's apparently non-feature extraction and feature extraction. It's a really odd description. Right, and then you have this table of I didn't know there's all these different types of entropy. For example, there's spectral entropy, which we are doing. I don't know what's this single value decomposition. There is a paper from 1999. Yeah, that's how far most of these tools go. It's funny, they want you to buy this paper for 40 euro, which is crazy considering, well, first considering you can get it from the university website, but it's not secure. The download link. So that's the publisher's copy. The not secure link is a weird link, isn't it? No, I probably want to get rid of it. There are multiple. Yeah, I don't know what's this PS. What's a PS file anyway? It's on ResearchGate. That's handy. Sure if I'm logged in. Yep. That's so much for 40 euro. There's the paper. Interesting, they're specifically doing EEG. It's a kind of odd arrangement of the electrodes. Then they do this task sound. Yeah. It's a very odd figure. Bunch of equations. Right, deteriorating sinusoid. You know what's this? States. But it getting higher when the sinusoid becomes noisier. They're doing desynchronizing 3D system. Yeah, this paper. Imagine finger movement from BCI recording. So call EEG BCI. Okay, that's fine. Interesting how they give the subjects initials. Right, so they're telling the subject to imagine them moving their finger and recording EEG. And in the EEG, they're looking at impedance. What's this 2 in the power of h? So impedance. How about this one? must be impedance as well. Why is it impedance? Don't understand. Right, so that's a power in a certain band. Don't understand what they're trying to show here. Like when you look at these two graphs, yes, it's the same scale. But what am I supposed to get out of it? Fractional pixels relate to alpha, read them, right and left event Qs are shown as solid and dashed lines. So there's some event suggesting that this is more correlated to the events and this is less correlated. Yeah, somewhat unclear. Spectral power. You can see some events. Yeah, here there was activation before an event. It's just very noisy data. Not sure what they're trying to show here. This looks like doing something, but yeah. So that's so apparently the temporal and spatial complexity measures the electroencephalogram based brain computer interface. So they use this singular vector decomposition, supposedly. SVD mentioned. Where is it? There's no absolute complexity. Yes, apparently correlation goes back to 83. It's exponent 85. Yeah, I have to look at those separately. Normally, when you read those, yeah, but I can't read those old papers. They don't make any sense to me. Need someone more recent papers explaining it. Yeah, it would be good to know what's the difference between those different entropies. There is approximate entropy, but then there were a bunch SVD entropy, spectral entropy. Spectral entropy, do I need to cite this paper from 1991? Is it accessible? It doesn't look like. Need to purchase PDF from 1991. How much does it cost? 40 US dollars. Nice. And normally you look at these 4 other versions, and normally like ResearchGate or something, that's a citation. So yeah, don't think it would be available. It's funny how this one shows one citation, but it was cited almost 400 times. Yeah, I would not cite anything that I can't get access to. Should be able to get the author's copy somewhere. But Yeah, I have to look at it offline. But from that paper, essentially, I learned that well, yeah, that there's different types of entropy that you should be looking at. I'm not sure what the difference between them or so it would be nice to have a tool that compares the three different entropies. They had this nice table. Um, where was it? Back. Yeah, this table um, also gave more information. So this is the function that they suppose that they developed, but they just essentially put the mathematical equation into what's it, Python. Yeah, that's great. That's useful. You do need to compare it um, to another language probably just to see that it was implemented correctly. Or sometimes, like I've seen in entropy, we have this tool on entropy where the what's not showing us anything. Right, it's just flicking between ECG, EEG, and the second one. Huh, this is weird. Yeah, entropy 1 and 2. So this is MATLAB entropy, and that second one would be LabVIEW entropy. And it's just sitting at this like super a high number. Something's wrong with that. What? Right. It's actually yeah. So black is black. Is that second entropy is the it's confusing, but essentially it's the problem with this chart, and that's why I added this LabVIEW entropy removing or displaying it option is because the scale is different, and yes, and it's just not calibrated that measurement. So the black when you remove the LabVIEW thing, which is red, it will look like this. This is the black line. So obviously, when you put something super large on the same graph, the original one just seems to be flat, to be as expected. And then, oops, yeah, I have to make this better, probably. Yeah, it would be nice. So we have this one, which is pretty straightforward. In this tool, you can select your signal example. Some of them were too large, so then this measurements will go through the roof, and this will again seem to be like it's just zero. Because the values are pretty small. Anyway, so this one will be regular entropy, which I assume is it's not actually here. Let's see it. Yeah, spectral. Sorry. So it will be a scalar. So one number. So then says this H-Jorf will be two numbers. One number, power spectral density, intensity. is an array. So we have it. Where do we have it? Spectral density. Yeah, we have power spectral density for this noise business, which, what's that? It's just random. So yeah, it's just a random spike. So much for random number generators. Yeah, one thing we need to do is make a video on this stuff. So we have comparison between different types of noise. Can select your noise type, and you have time and frequency domain as output. Awesome. Put it full screen. Bit just. Why is the screen not going any bigger? It's 100%, but annoying. Yeah, this is 100%. Right. So I have this comparison between different types of noise. You can select your noise type. For example, uniform white, Gaussian white, periodic, or inverse frequency noise. You can select your amplitude as per usual. You could also add a sinusoid to it. So as you see, the noise amplitude is 0.5. So once the sine amplitude goes above that, you start seeing this peak over here. You can set its frequency as well. So this can move around. So you see that the sinusoid here, so it should be 10 waves in here because it's 10 seconds, and we have a sinusoid of 1 hertz. Now you should have 20, and you can see how for different types of noise, if you set this to 1, how it's almost not visible in the time series and barely visible in the power spectral density, but then for different types of noise it becomes much more prominent. So the signal to noise ratio is much higher. For uniform white, a bit lower. For Gaussian white, and very low for inverse F. And this is with the sign amplitude being double the noise. So with this you increase it higher, the signal becomes more prominent. You can also change from logarithmic to linear scale. You can also zoom in on any section you like. So this way you see that 1 hertz better. You can pan this way or use the mouse as well. Same here, you can select the section this way and see the effects of the noise. You can lock it in as well. And see what difference that makes. Just reset all that. So inverse F is also called fractal noise, also known as pink noise, and it's generated by passing a spectrally flat white noise. So we're taking a white noise and passing it through a frequency so that levels drop by 1 to 3 dB every octave, as you can see here. The current setup has 5 first order stages of the inverse F filter. So that's how aggressive the filter is. You can read more about the functions that I use for this in these links on the front page. And this is pretty much it for this tool. Get out of oops. How many times this will look on a mobile device? Just not a great view to prove that why they're not aligned this way. We said we're not going to do any development on a weekend. I also started recording them locally as well because, as I said, when I download it off YouTube, it's a much lower resolution. So I don't want to lose any resolution from it. It's funny how Firefox is scaling all the screens together. So just scaling one at a time. Anyway, just looking at how to make this more mobile friendly. be hard, wouldn't it? Yes, obviously when the sign amplitude is 0, this one doesn't matter. Log green linear matters a lot. When it's in linear mode, it normally should probably just scale down the axis to 0, between 0 to 50 or something. We can see what's happening. And obviously in log scale, you get a different picture, but it's skewed. So I guess it mostly depends what is it you're normally used to looking at. People asking to make the videos shorter, so yes, they would be. It's a work in process. I'm cutting all these bits out, but this editor is not great to also listening to my own live streams at like double the speed because I'm speaking so slowly. This editor just why and how anyone would use it. I'll just save this one. I need to add tags onto it as well. It just takes forever. We also have an EEG feature extractor that labels different EEG components, ECG components. This is a ECG feature extractor that labels different ECG components, as you can see by different colors. So this is not labeled, this is labeled. This one actually splits the ECG wave into 4 waves, the original one, a T wave, QRS, and P wave. In this tool, you can select the different examples. In this case, you can see it's making a few mistakes over in the beginning here. But then seem to do better as you go. This is, by the way, a 30-second signal. This is, by the way, a 30-second signal, and this is how long it takes for the algorithm to kick in and start labeling. You can see these are the two mistakes that it makes. So it will be a false positive, false negative. You have another example of hyperkalemia. Why? That's weird. Where the T wave is inflated. and this marking is correct. So the QRS there is the black as per this description here, and the red is the elevated T wave. Here you can select your window size. You could also use those for automated scrolling and moving along. In this case, because it's just the 30-second window, so you can just scroll through the whole thing. And yes, there's nothing past 30 and nothing. You can go all the way down to 0, and you can use your mouse to zoom in and out. It's pretty handy. But for this to work, for the scroll to work like this, the whole signal has to be loaded into memory in this particular with this particular architecture of the web application. This is again how long it takes for the signal to kick in and start working. Normally I'll display this is just showing one not labeled and labeled stuff, so you can see the difference. And it will also give you some measurement of the heart rate mean. This is for the entire 30-second segment, not what's selected in this window. You can add this option later, where this calculation will be just what you are currently looking at. You have PR intervals, that will be the interval between this peak, the P wave peak, and the R peak. Then you have the QRS time itself, so essentially how fast or slow the QRS peak is. And then you have the interval between Q, which is this bit here, and the T wave, which is almost double, more than double the length. And you also have the isoelectric voltage level mean. So that's essentially the fluctuation in the amplitude. There's more information at the bottom of the page, like what LabVIEW functions were used in some relevant papers. And do let me know if there's any bugs that you notice or anything you would like to be different with this tool, or any improvements that you would like to see. One of these things, for example, is obviously there's too many numbers after the decimal point here. It can be cut significantly. It can be cut back. We'll do it next time. We said we're not gonna do any development today. get out of full screen and move to the next tool. I think we covered this one already in yes, we did. We did it in short video, however. So it would have been a vertical, not horizontal. Didn't look very well, so we could cover it again in a horizontal view. Right, so we can do this one quickly. Should take a couple of minutes. Open full screen. Right, so this will eventually replace this video here. Some of those videos actually incorrect, they're not correct links, to double check. And yes, this tool will need more details and the like. So here you see, just trying to get my microphone. No, it shouldn't be going directly into the mic. The sound level. We want a good sound level. So here we got a synthetic EEG signal generator. You can set your window size. 5 is default. And then with those you can control this spectrum. So you can set higher or lower delta band. Once you set the amplitude, you can change the width of it, so bandwidth. So it will have the same energy in it. So if you set it too wide, then you'll have to increase power in it for it to be visible there at all. Same for theta and all other waves, but yes, they look and feel different because the filter has different bandwidth. Same for alpha, so changing your amplitude and bandwidth. Again, it will have the same energy level. So once you make it wider, the amplitude will go down. The grayed out, the gray area there is the composite of all of them. And finally you have beta, which is a bit isolated in its frequency. But that's the gold standard, the literature standard. At the bottom you have the LabVIEW functions used to make this web application. The API is available for you to use and create your own user interface, because yeah, this one is not ideal. And in the future we will add the standard option to convert this to log scale or back to linear. And if you would like to see anything else or find any bugs, please do let me know. There is no bug bounty, however. This is a not-for-profit project. Also, not entirely sure why this one keeps running forever. For some reason, the way those controllers work is that once you move them slowly, it will keep piling up GET requests from the API server, which I host myself as well as the same server where the website is hosted. But they treat it as two separate things for, I guess, security measures. But this will keep running for a while. It will stop eventually. And this is just unique to this type of controller, this slider. Because when you use this, it doesn't do that. I guess it's because it has a lower resolution. So when you, the resolution will be set. You can set it, you can change it for this as well. I have to check it and compare. Those sliders with different resolution. I would imagine it will send a different number of GET requests. But then it's also quite responsive, so you do get the last one essentially. If you reduce the power or all that, that's how it should look like. So this is delta alone. You didn't have to. This is changing the bandwidth of delta. Oops. Keep scrolling by mistake. This is theta alone. Should it go all the way to 0? Probably not. Oh no, it should. Sorry, it should. Alpha. Does it look too similar? Right, and this will be, you can tell this one is higher frequency. And yes, you can change the bandwidth as well. So this will be essentially noisier. And this will be essentially just that one frequency. And why there is no overlay? There is no overlay. It's annoying. Maybe. No, you don't have it at all. Have to fix that as well. It's not a major thing. It's not a bug. It's a feature. Isn't that what we always say? I meant like an overlay like this. It is responsive, so it's not hogging the server or anything. It keeps sending requests. I'm not sure why it keeps refreshing the window, because in theory, once it's done, it should have stopped. But I've been messing around with this for a while. It's been a problem for quite some time. So I just kind of got used to it. Yeah, get out of full screen. Yeah, eventually it will stop. So we did this one. We did that one. I don't know why the order. Did this one. Signal generator. Yeah, it's an interesting one. The other thing is the signal generator, the EEG generator. So we could now start combining these tools. So essentially, with any EEG generator, you potentially want to inject some of this inverse frequency noise into an artificial wave. Well, because essentially you'll pair them this way. Oh, by the way, I don't know why the paired. This should be still related to EEG. So we should have EEG. Probably should group them differently or something. Finish this. Sooner rather than later. Then it's been almost 2 hours. We haven't dropped any frames, which is great. So we haven't dropped any frames, which means the settings are okay, good. The internet is fast enough. I'm also recording now locally as well because as I said, the ones if I just upload to YouTube and then download it, the resolution is much lower than what I can record with. So essentially, it's 720, not even 1080p, which is super weird. And should we do another one quickly? I'm just looking which ones I haven't touched for a while. Supposedly we don't have. It's with this icon should actually look like that, this image, because they are similar. And let me just open them again. Let's have a synthetic, sorry, this is ECG feature extractor. This is the EEG generator. Change the name to actually have generator in there. ECG generator. I think we covered that one already. Coherence, cross coherence function. So it's this one here. Yeah, from memory we covered this one extensively already. The statistical analysis, yeah, it's not my favorite. It has EEG, EEG, it has a bunch of other signals. There's some problems with it and it's over complicated. It's too much stuff on the screen, so probably eventually we'll go. There is a video on this one that's pretty basic. Oh, yes. Yeah, the channel is just noisy. I have to load more. We can add actually another version of this, but loading one that another file that actually has seizures and the like. This will be the highest quality EEG you can possibly get because it's being recorded straight off the cortex of the surface of the brain. It's a animal model, intracranial EEG. So we like it because we are sure, we're confident that there is whatever 90, whatever almost 100% EEG in it. So these things, I don't know if they still could be some EMG or some artifacts, whatever, but it will be very high quality signal. So whatever other signals you get from anywhere else on the head or any types of sensors that people put dry electrodes on, so forth, they should always compare it to something like this in terms of signal quality. So the signal to noise ratio will be super high. We had that, this one, so we haven't covered. This is the one. I mean, it's fairly similar to that, wasn't it? I think this one we made a change, so it's by default left and right channels and 300 separation. This one is a window of yeah, 4 is maximum. Yeah, that makes more sense. It used to be 10, but then it becomes less responsive. Again, there's a lot of data in this chart. Yeah, it becomes quite heavy. This one should be nice and light, because it's already pre-recorded stuff. Yeah, we want logarithmic scale in there as well. All spectrum, yes. Ideally, yeah, in when you select your linear, it will cut it at 40 or 50 hertz. Yeah. And when you go log, it goes all the way to 200. And should this be in the background? I'm pretty sure I tried doing it didn't work. Yes, we got annotations, we got feature extraction. So this is a very powerful tool, but it was optimized, I think, for this image. I don't know if it would just work on EEG or ECG just out of the box. I suspect not, but we could just try it out. And same for fuzzy logic. This will detect this signal. You have these settings that does about 50% detection error. Yeah, this one we will come back to. This log, yes. This one has a wavelet denoise. That's weird. It looks very different in the log scale. It's been 2 hour stream. I'll make it shorter later. Get rid of all the silent beats and label it, and also cut out some some standalone sections out of it as separate videos. So I can put them on the site as well, explaining some of these tools, like instead of those videos there. I'll just do it for all the current tools. There's not too many, and there will be more coming very shortly. So stay tuned. Please subscribe to my channel. Put comments and likes and the likes and the like. And I'll see you next week. Bye.